and we're going to move on to the rigging tools. So apologies that I'm going to take two big sections right back to back. But this is we're gonna pivot over into Maya's rigging tools, which right now don't have an overlap with USD. And I see some thanks going on in the chat. You're absolutely welcome. We're very excited about Maya USD and everything it's bringing to the table. USD is a fast-moving train, and it just adoption of it in the industry is really not a question of if for anybody's pipeline. It's really a question of when. So it's really nice to jump into this and familiarize yourself with it. If your studio hasn't adopted it yet, play with it. Let us know what you think. That GitHub forum is a fantastic place to put feature requests and understand where we are. And all development is in the open. We're not developing any features in the private. So if you see pull requests in there and you see us actively working on things, those are the things that are coming to the plugin. So engage with us. It's our first time as a team doing an open source project, and it's going really well. And we've gotten a lot of really meaningful contributions from all over the industry. So please join us there. Okay, so now with I'm gonna look over our attendees. Okay, I don't see, all right. We'll go on to the rigging section. So with rigging, well, I'll skip past this slide before I talk about that. It's another intro slide. For those of you that tuned in late to this talk that didn't catch the head in, this is who I am. This is what I do. Background in visual effects, 14 years at Rhythm and Hue Studio, a few years at Blizzard Entertainment, and a few years in a VR company. So this is the experiences I'm trying to bring to the table for the teams that we're working on here. Okay, so I want to talk a little bit about what the rigging goals have been. With Maya 2020, if you're familiar at all with that release, you started seeing us dip our toe into more procedural workflows. Things with the offset parent matrix, we're really looking on switching things from creation state, where when you create something in Maya, a bunch of data is cached away in an inaccessible way or in inconsistent ways, and move to something that is more rest state based, where you have your current state and your rest state. And if we go there, we have a lot more functionality that we can perform. Along with that proceduralism, we want a system that, with proceduralism implies that you can change your inputs and get a different result by running it through the same procedure effectively. And so a lot of Maya, because it's creation state based, it does a lot of things really well, but it's really not built to expect change, right? It kind of assumes that you've got a final model and you're doing your final work and you're not going to redo it, right? You don't want to start over and redo those things. And that's not realistic. That's not the real world. And so what that is forced a lot of studios in is every studio that's using Maya in their character pipeline is leveraging build scripts in some form or fashion. When they build a character, they're finding some way to capture that build process. So if the inputs change, they can replay that build process to get back to where they were and continue on. And there's a lot of inefficiencies to that. There's a lot of overhead and a lot of manual change that are going on. So a lot of the changes that we made is about expecting change and allowing for that change. And one way we want to do that, like I said, we hit transforms in 2020. We really want to hit the deformation and geometry side with 2022. And so a big part of that is supporting topological independence, right? Just because somebody splits a poly on a model doesn't mean that all my weighting information should be useless, or I shouldn't have to go clean that up in a meaningful way. And so I'm going to talk about some features that really help move us forward in that procedural direction. Okay, so the first one is a feature called component tags. That's a name that we settled on. It's not an existing name out there, so I'm gonna don't be surprised if you don't know what component tags are yet. I'll be telling you what component tags are. So component tags are effectively name sets of components that are stored on the shape itself. So right now, if you use a deformer and you create membership, you might be aware, if you looked at the node graph, that Maya creates a group ID, a group part, a deformer set, all these things to basically maintain a collection of components that the deformer is going to act on. In other ways, you might be used to Maya object sets, where you create a collection of objects and they all sit in this object set. So instead of dealing with those extra nodes and extra graph connections, what we're doing is we're saying the shape owns the components, so the shape can own the collection of the components. So we're creating these named components on the shape itself. And I'll show you what that looks like on a character here. So this is a character that already has some component tags. Right in the attribute editor, you can expand the component tag widget, and you can see all the ones I've created: arms, arms lower, feet, and you see information about the component tags there, where they were injected in the history, how many components they have. I can click these icons are showing me whether they're face types, edge types, vert types, and I can click on these as I go through. Now, keep in mind that each component tag is homogeneous. It's all faces or all verts. But if you want one that's vert and another one's faces, you just create two different component tags. And I can get a little bit more into ways to leverage that. So that's what browsing existing component tags looks like on a character. This is just a close-up look of that widget. It also has some editing functionality in it. So if you were to right-click on one of these, you're going to see a menu that looks like this, where you can also select them. You can delete a tag, rename it. If you're going to edit those component tags, this is where you would come to replace them or clear them or add or remove from an existing set. Okay, so let's look at how you might create a component tag if you have a model that doesn't have any. So we're going to grab this guy's ear hole. At least I think that's an ear hole. We're going to grab that and we're going to throw it in a component tag. So I'm just going to use traditional Maya modeling tools. I select a face, I grow the selection, and now I come over to this widget. I add a component tag and I rename it. Pretty quick. So I called this thing ear. If I go back into it, you can see that ear exists. If I click on it, it's going to select ear. Another thing that you'll notice in the trend is we're trying to leverage the attribute editor a lot more. We're trying to put the tools you want at your fingertips, and the attribute editor is very context sensitive, and based on your selection, it's always there. So we wanted to make sure that we were putting this tool in a place where you didn't have to go dig for it or hunt for it to figure out where you manage these things. It's always right there in your attribute editor. So that's creating a component tag. So now I already alluded to this a bit, that component tags, one of their primary uses, so I'll stop. First thing is, component tags are nothing more than named collections of components. That's all they are. So anywhere where you need access to a name component collection, you can leverage these. But the first use case that we're using them for here is for deformation. And we're using them to replace group IDs, group parts, deformer sets. So I'm going to show you how you do that using what we call component tag expressions. And this is something that lives on the deformer itself. So I'm going to grab this character and I'm going to create a cluster. And it's a cluster on the entire character. So when I move it, you can see the entire character moves. But let's go and let's look at that cluster in the attribute editor. So we'll select that cluster and you'll see there's a component tag column there that has an expression in it. It had an asterisk in it, which meant it was a wildcard. It said, I'm going to act on all verts that come in, but I can give it a name. I can give it the name of a component tag that exists on this character. And right now I'll give it the name pouch. Now this is an expression. So I can actually say, give me pouch plus strap. So it's Boolean operations that you can perform. I can say pouch plus strap minus belt, and that one little piece pops back. This is also a place where to do certain Boolean operations, you can use casting. So you can cast a faces to verts or verts to edges. And we have the ability to expand that language for you to do common operations of being able to cast from one type to another, to convert from one selection type to another. So really powerful. And you can see how this starts to help with proceduralism, because before, when you create these deformers and you define a membership, it holds a fixed set list of components. And so if the incoming model changes, the component list is completely scrambled. With this one, as long as you pass out a model that has pouch defined or pouch and belt, which I had in there, as long as both those things were defined, this deformer will continue to work and it will just act on the verts from that collection. Now, don't confuse this with weighting. There are two components to deformation. There is membership, which basically says, all right, which verts can this deformer act on? And then there's weighting that says, okay, based on that calculation, how much am I affecting each vert? So right now we're just talking about the membership side of that equation of what we can act on, not how much we're acting on it. Because I didn't define any weighting, we're acting on everything 100% at this point. So we haven't gotten to weighting here. We'll touch on that in a bit. So now let's talk about editing component tags. So if you have a component tag that you want to modify, we'll take the one we created earlier, the ear component tag, and we'll see that I left out a sliver on the edge. So I'm going to I'm going to go here. I'm going to grab that sliver that was left out. That bothered me. So I want to complete that ring. Now, like I said earlier, you just right click, go to components, and you can say replace. That entire selection now replace the existing component tag. And so now I've updated it. I have a clean component tag. The next thing is dynamic membership. So the way you've handled membership on Deformers before is kind of a one-stop shop. And we've kind of broken the concept into two different places. Because these component tags can be reused, multiple deformers can point at the same component tag, whereas that wasn't really easy before when you had group IDs and group parts to say, oh, hey, I'm going to define a membership on one deformer and I want another deformer to use the same membership. That wasn't defined very well. So there's two sides of it. There's the consumption of the component tag where you define with component tag expressions, and then there's the component tags themselves. So you saw earlier when I was changing the expression that the membership was changing. So that was the deformer changing it. But the deformer will also update if somebody goes upstream to the mesh and edits the component tag itself. And so that's what I'm going to show you here. So this character is going to have a deformer on it that's going to smooth out almost its whole head here. So here I've smoothed out its entire head, and I want to isolate that to this nose section. So I'm going to give it an expression for the component tag nose, which is basically represents that. So I'll go back to this delta mush here, and I'm going to set it to nose, and you'll see that now that deformer is only affecting the nose, but it's affecting the nostrils. And so maybe I feel the nose group was a mistake and it shouldn't include the nostrils. Maybe that should be something else. So what I'm going to do is I'm going to go back to the existing model with the deformer still on, and I'm going to edit the nose group. And what you'll see is the deformer will update to respect the fact that those are no longer a part of the nose group. So that's a bit of a spoiler alert while you watch me grow this selection and turn it into a nostril that I'm going to go to the shape, and I'm going to pull these nostrils out of that nose component tag. So I'll right click on it and I'll remove those. And you notice that they jumped. That's because the deformer that's downstream that's using nose is no longer pointing at those because they're not a part of the nose anymore. So that's a great way. That's another way that you can affect membership. Now, keep in mind that change would affect every deformer that's using the nose group. That would pull the nostrils out for all of them, which is why sometimes you want to be dealing with component tag expressions. Other times you might decide you have the wrong component tags in your shape and you need to edit those directly. So let's look at some of the other effects of this. Okay, so let's look at some of the other effects of this. So one of the things we talked about is this is an alternate to the group ID group part section. So if you look at the graph here that's on top, you'll see a very complex graph, and that's the graph you get if you create, I think it's a cluster. If you create a single cluster, you get all of those nodes on a shape. And with the new component tags, your graph looks like the one on the bottom. This is not a node editor where we've hidden auxiliary nodes or anything like that. Those are all the nodes needed to deform this thing. So it simplifies your graphs, reduces the number of connections. And this goes back to the ability to edit rigs as opposed to having to replay a build script. With that graph on the top, you're not going to go hand edit that graph. That would be brutal. You're going to rebuild that graph from scratch. The one on the bottom, you have you're probably much more inclined to reorder some graph connections and play with that if you need to. So it does become easier. The file sizes get smaller. The evaluation gets faster. There's less plugs to pull on. So it's overall a win. So I'm going to show you that process right here. So here I'll create that deformer, that cluster deformer, and that's what it created, all of that stuff. Deformer, group ID, group part, deformer set. Not only that, it created a tweak node and its group ID, group part, and deformer set. So these settings I turned off intentionally to show you the old way. But here in the options, you can say, hey, do we want to use component tags on creation or not? And you can also say, do I want to create tweak nodes or not? This way you can create tweak nodes on demand because 90% of your pipeline is not leveraging the tweak node, yet they're littering your graph. So this is what it looks like when we turn those settings on. And so that second iteration is what Maya is set to by default. If you would like to create the old style node graph and go back to group IDs, group parts, and tweak nodes, you can go find that setting in the options menu. Another thing that's fantastic, that's just a creation time setting. These can coexist in the graph together. So if you have a character that has some component tags, some group IDs, you can do that. Just because a character has been built one way doesn't mean you can't create a deformer using the other methodology. So that's really just affects what happens at creation time. Both graphs are supported. Okay, and this shows you that. So conversion, here's a character and I just have one node I want to convert. Through this menu, I can right click and say convert to component tag. And it converted that skin cluster to component tag. Or I could say, I want to hit the whole scene. So I go to the plugin manager, I can load this convert to component tags plugin. And then there's the command down below with the scene flag. And it's going to take the whole scene and it's going to get rid of all group IDs, group parts, tweak nodes that it can. And there's a few flags and convert to component tags that you can pass it to kind of nuance the behavior you want. Cool. So that's how we use component tags for membership. There's another use of them. Remember I said they're just collections of sets. So there's other ways that we can use these things. So if y'all have been playing with the proximity wrap that shipped last year, what you may have noticed is in situations where you have a cage driving it on the mesh, you might have verts that bind to the wrong side of something. So that's where we've introduced using component tags with a feature called bind tags. So this is a low res cage that's going to drive this high res jacket. But you notice if we just do straight up proximity wrap with this, you're going to get shredding right down the middle because these verts don't know which side to bind to. But what we can do is we can define some component tags on each edge of the cage and the geometry. And we give them a specialized suffix. In this case, it's _prox. And then on the proximity wrap itself, we have the ability to check and say, use bind tags, and we tell it what suffix to look for. And when we turn that on, things won't bind to the other prox groups, and it cleans that up. So it keeps it nice and procedural. You don't have to get in here and work with individual weights. And so you have a procedural system. So if this jacket changed or if anything changed, as long as those component tags exist, you're going to get a clean bind on your jacket. Okay, so that's all component tags. Let's get into Falloffs. We kind of broke things into two sections, right? We have membership and we have weighting. So Falloffs are addressing the weighting side of the equation. So what Falloffs are, and this is going to probably sound a little technical, but they are networks, node networks that build up a weight function. And that weight function is passed off to the deformer, and the deformer evaluates it once it knows what geometry it has. And you don't really need to know anything about all that except to know that that means it's topology independent. It means these networks can be reused, and they're extremely efficient in that regard. So one type of falloff that you can build into a network is called a primitive falloff. And here's an example of what that looks like. So I want to make a belly jiggle. So I'll just create a cluster on this whole character. And so you'll see I'm affecting the entire character, but I want to isolate the effects of that to this rhinoceros's belly. So I go into this widget, I right click and I say, create a primitive falloff. And it's really small and seen right now. I'll scale it up, but it created a sphere, a little sphere primitive down here that now wherever that sphere intersects this character's skin, it's going to drive the weighting. And that's going to be evaluated by the deformer on this particular mesh. So if the mesh was changed out, or if a different deformer used it, they could still evaluate using this procedural falloff. So this one, I'm just going to shape it so we get a better shape. I should mention, I put some notes on here, but these assets were provided by Create 3D Characters. These are some awesome things by Andrew Silk and the team over there. So they've done some amazing things with it. So these are really cool characters to show this stuff off with. I'm excited to show it. So here's me just probably spending too much time shaping this to show you the different features. You can play with the fall off curve. There's kind of an inner bounds and an outer bounds. The dotted line shows the outer bounds. That's where the fall off ends. The inner bounds is solid. So that shows where it starts. There was the weight visualization, so you could see how these things look. So that's the fall off. Now this is a bit of a blunt tool. So you can actually end up picking up parts of the character that you maybe didn't want to pick up. So I show an example of that where that belly is picking up part of the leg. So if I go and I manipulate this, you see the front leg is getting picked up. Well, we have another fall off that's called a blend fall off. And that's a great way to combine other types of fall off. So here we're going to use a blend fall off to combine two primitive fall offs. And you'll notice that the other fall off I have sitting under his nose right now is inside out. I flipped the start and the end. So it becomes negative. So when I move it over, it's going to carve away influence. So here it's coming in and it's carving away at the leg. So now we've taken this blunt tool and we've gotten really targeted weighting that's still procedural. We can subdivide or poly reduce this rhino to our heart's content, and it's still going to deform correctly. Then you go into the blend. You see there's different blending modes. I'm going to show some up here that'll be garbage like divide, but basically all these are putting out values from 0 to 1, and these are just like composition modes. You can just say what operation are we combining them with and play with them different ways. By default, I really like to stick with multiply, but there's a lot others here that you can play with. Okay, so this primitive fall off actually has two modes. It can also be a planar fall off. So I have another one of those that's the sphere at the back. You see his back legs in the effect, but maybe I don't want to carve out just the leg. Maybe I can be a little more blunt than that. So I'm going to take this other fall off here, and I'm going to change this primitive fall off. It's the one that's already created, but I can go into the fall off type and I can change it from sphere mode to plane mode. So now you can see that as I bring that in, it starts carving away some of the effect of the back leg there. So you can see it kind of taking out the shin some. So now we've isolated this fall off. I don't know where we are in time. If somebody wants to let me know in the chat how we're doing on time. Okay, so we've seen blending of fall offs. We know this is a blended system. So what about weight painting? Okay, let's go there, right? So we have a type of fall off that is called a component fall off. And this is really just a weight table. Now, fall offs are meant to be topology independent, and weight tables are very topology dependent. You have a value for each individual component and each individual vert. But we've worked around that problem. So we do have this component fall off, which in and of itself is a weight table that is meant to be associated with a certain geometry. But we have other fall offs like a transfer fall off that can remap those on the fly through data flow to different topology. So what that means is if we have this fall off system for painting falls, I'll show you how we can create that. Here we have this deformer it's going to be a jaw. And so if I come into this cluster that represents the jaw, I'm going to assign a component fall off, which means, hey, I want to paint this fall off, right? So I'll right click on this and I can come down here and to paint this fall off. And it's your traditional painting interface that you would see if you're painting the weight on any cluster. So I'll set it to replace. I'll do my poor man's version of weighting on this. It's been a while since I've been in production, so I know y'all probably have much faster techniques that you use to get at these weights, but I'm just gonna get a rough selection of the jaw. I'm gonna flood it and I'm gonna smooth it a bit just to get that jaw in there. I want to do a coarse grain deformation here to show you this effect. So here we go. We'll grab this thing, we'll paint it, pop open the paint tool, set the value to 1. We'll go ahead and flood that value so we affect the whole thing. I'll smooth it so it's not so rigid at the edge. Just kind of drill that down. And now when I open the jaw, you're going to see this jaw open with a fall off. But the corner of the mouth is pretty squared off, and I don't like that. But maybe I like my base level weighting and I don't want to go touch it. So instead of that, I can use a blend fall off and I can add another component fall off to this and I can layer them together, right? So there's a lot of people that really want layered workflows in here. So we have the ability to create this other fall off. We'll bring the second component fall off in here. This also could have been another layer within a single component fall off, which we're not talking about, but I'll try to cover that at another time. So now we'll select that other fall off, the second fall off, and I'm just going to paint out the corner of the mouth. And keep in mind that this fall off and the other fall off are compositing together. So here you'll see I'll just kind of knock some of that weight out. And this again is non-destructive. It sits on a separate layer. I smooth that out. So I've rounded that mouth a little bit. Now if we go back to the blend fall off, I can turn the effect of this on and off because it's just a fall off in the blend. So all those can be disabled. So I like this shape a little better. Maybe your director may not, but I didn't spend much time on it. And you can see I turn it to no operation, and we can see we're toggling off that effect while still keeping the base layer there. So extremely effective way to incorporate layered weight painting onto this fall off system. And keep in mind, this blend fall off is agnostic. It'll take any fall off you want. And there's even a fall off API if you want to create your own fall offs that can be registered with this system and blended together. So very, very powerful system. Okay, so that's the basic gist of fall offs. Both component tags and fall offs go really deep, and I just don't have the time to go deep here. So hopefully later on Twitter or on some area blog posts, I'll be able to put out some more content for you to help you dive deeper into these tools, because there's a tremendous amount of things you can do. These are really just building blocks that you can combine together in all sorts of permutations to kind of land on the final result you want. They're not single purpose things. They're meant to be more general purpose and combined together to get different results. You can already imagine where you might be able to use a lot of tools we put out to replicate the soft mod with more flexibility using fall off. So just something you can think about there. So now let's talk about some new deformers that we've created. The Solidify deformer is a really cool deformer that saves a tremendous amount of time. And what it allows you to do, it allows you to work with layered weights in a way where you can create base layers and allow parts you don't care about to just shred. You don't care, like on this character, if I want to paint a muzzle control, I only care about the skin. I don't care about the horn. I don't care if the horn shreds on me when I'm painting the skin, but I do need to come back and I need to correct that horn. And that's where the Solidify comes in. You'll also notice the Solidify is going to be another creative use of component tags because it's going to act on a component tag. So here's the rhinoceros. I created this muzzle control. I know this is breaking anatomy, but a lot of directors will ask for something like this. And you'll see it shearing the horn. So I'm going to create this Solidify deformer, and I'm just going to give it the horn component tag. And you'll notice that the horn just corrects itself, right? It creates a rigid version of itself. It follows the skin. It blends into the skin nicely. You notice the back horn is still shearing. So I'm going to use an expression to add the back horn in here. Now the back horn's corrected. Right? If you think about the things you would need to do this on your own, you would have to create some sort of locator that is following the skin, that's building a coordinate system, that has some original state of your geometry held rigid, and then you'd have to set up a blend shape to blend back. Tons of stuff. This is GPU accelerated. It's super fast. If somebody added a third horn to this Rhino, as long as that third horn had its own component tag, this deformer would start working on it, right? So you could have two variations of this Rhino with the exact same rig. One has one horn, one has two. They have the same deformation chain, and you don't need to touch the deformation chain. So really, really powerful tool. And like I said, one more use of component tags, how you can use those name selections. Next deformer I want to touch on is the morph deformer. So the morph deformer is just a straight up A to B morph. And there's several things that it brings to the table. One is it's GPU accelerated, which is fantastic because you can use this to blend in non-GPU accelerated deformers that you may have created in-house into GPU chains without blocking GPU evaluation. I want to touch on one thing. We made an improvement to GPU evaluation to support more design patterns. Used to, if you had what we call a fan-in design pattern, where you have multiple deformation chains that merge into a single deformation chain, everything upstream of that branch would be blocked from being evaluated on the GPU. So we call that fan-in. Fan-in design pattern is no longer a blocker for GPU evaluation. And so using that along with this morph, if you have a CPU version of a deformer and your studio doesn't have support to upgrade that to a GPU deformer, you can use it. And then you can use this morph deformer, merge it in. And the fact that you created that fan design pattern won't block the rest of that chain from GPU evaluation. Now, it's not magically going to put your CPU deformation on the GPU, but it will allow more of the deformation chain that was already there to evaluate on the GPU. So it's a very powerful function in that way. Another thing that it does, it'll do partial deformation, and I'll show you that in a second. And it also has lots of spaces that you can work in, surface relative spaces. You can do absolute mode or additive mode to where it's either going to stomp on prior deformation chains or add to them. So I'll show you this. So here's a character that this is one mesh, and what you see at the top left is you see a single cluster that's just moving a jaw on a head. I unfortunately don't have this on loop. And then you see the hair, which is just kind of as a sign deformer on it. So if you're using a blend shape and you wanted to do a bunch of head targets with blend shapes, you could do that. And you could trim it down to be just the head. But there's a trick that a lot of riggers know on how to make that happen. And it involves reordering the vert table of the mesh itself, where what you do is, if you don't want to have all your head targets be the entire character and you just want it to be the head, you go back to your base mesh, you cut off the head, and then you recombine the mesh back together so that the head starts at index 0 of the vert table. And so then when you do a blend shape with something that's only the head, they align up and the blend shape works. But that breaks down if the character was a two-headed character, right? Because only one vertex can be at index 0. So it's a hack. It kind of works once, and it puts restrictions on your modeling pipeline. People have to change the way they work to make that happen. So it's not exactly the way we want you to work with it. So this morph is this A to B morph. Like I said, it provides this GPU legacy support for CPU deformer kind of effect, but it also does these partial deformers. And what you can see is, oh, sorry, I skipped on to the wrong one. What I'll show you here is in this chain, what you can see is this component match node. So what the component match node does is a morph is nothing more than a vertex lookup from one mesh to another, saying which vert in that vert table over there should I line up to, and it goes to that position. So what component match does is it builds an association. It's like a lookup table that lets you use an alternate lookup into that mesh. So we have the ability that these will be created for you under certain deformation modes, but you can use them for other meshes if you like. There's other tricks you can use for this. And there's the potential to generate these lookup tables in a different way. This is the only way we've currently done it, but you could potentially put different matching algorithms in there to get this. So that's how we've got the hair and the head working at the same time on this character. The other thing you'll notice is we're taking advantage of spaces. So this character is using a surface space. So this doesn't use transforms to build up a coordinate system. It's simply using the mesh to determine what space it's in. So you'll see this character, his head has a skin cluster on it and his head is tilted back. But you'll notice that when his jaw moves, this jaw motion, it's happening in the space of the tilted head. So there's a lot of spaces to play with. And like I said, this can be an absolute deformation, world space deformation, be additive. There's things that you can play with to get. So it's a very robust deformer. It's a very single purpose deformer. And what it does is it carves out a use case for the blend shape deformer that people have been using the blend shape for, because it's way overkill for the blend shape, into this special purpose. And it lets us simplify the use cases of the blend shape and potentially lay the table for improvements there later, where we don't have to worry about people trying to do these workflows within the blend shape. Okay. And so now we start combining these things, right? We've talked about falloffs. Well, those primitive falloffs, they can be animated, right? So here's an example of an animated falloff, and I've combined it with the effects of a morph. So we have a head on the far left that has a jaw with lips sealed. We have a head on the far right with a jaw with lips open, and I'm morphing between the two. So I'm doing a sealed lip trick with animated falloffs. So here's how you can see these. Like I said, these are building blocks. These are just common components you can put together to do more complex things. And here's one of the ones you can do. And then, like I said, we released proximity wrap last year with Maya 2020. And it had several modes to it. And one of the modes that shipped with it was called cluster mode. But there was no workflows built around it. And it was very difficult to wrap your head around how to build it or use it. What we've done now is we've put the workflows in. They're going to allow you to use that cluster mode. And what that cluster mode is, it lets the proximity wrap act like a skin cluster effectively. It kind of behaves. It works on matrices. So instead of on geometries, it'll work on matrices. So here, I'll show you what that looks like. So here's another Zoo Tools Create 3D character. I'll select the joints, got the skin. You go into bind skin, and it gives you an option of which node it's going to use to create it. You can switch to proximity wrap. You apply and close that, and this is all driven with proximity wrap. Now, when you look at this graph here, one thing I want you to notice is this table is using that component fall off. So it's using a weight table like we talked about. Instead of being painted, it was calculated by the skin cluster algorithm. And because we haven't changed the geometry, this component fall off could be plugged straight into the proximity wrap. But you notice it routes to a transfer fall off. And the reason for that is if we change our geometry, this proximity wrap will continue to work. Now, obviously, if you change it from an octopus to a rhino, you're going to get garbage. But if you change it from octopus A to octopus B, or you tessellate, or you split a poly, you don't have to go in here and reskin this guy. This transfer fall off is going to handle the remapping through data flow for you. And so that brings me to the end of the rigging stuff. Like I said, this is very deep. There's a tremendous amount of things here. It's hard to cover in such a brief period of time. So I definitely want to engage with you all on Twitter. I want to engage with you on the area blogs and try to get some more examples in front of you to see what you can do. In the last few days, there's some very proactive people, or last day, I should say, some very proactive people who've already jumped on this and already doing some pretty cool things that I've seen posted to Twitter. So please come have a conversation with us and let's learn how to use these things. And we'll keep pushing things forward for procedural rigging.